Hi, Ian Zepp here. This is a demo for Legacy Lens G4 Week 3 RAG-powered Code Explorer. I'm going to go through this presentation very quickly because there are a number of slides and I need to get through it in under 5 minutes. So this was built on AWS Card Demo, 40,000 lines of code, open source. Probably about 25 or 30 of that was COBOL. We picked Pinecone. It's managed. I don't have to manage it myself. It has integrated embedding models. It also has re-ranking, which we tested and didn't end up using. The fastest model that we tested or were able to settle on after testing was Llama TextEmbed v2. Best latency, highest relevancy overall. We did 16 different index type model combinations, 800 query runs, and this one consistently came out on top. Chunking. We did paragraph chunking instead of fixed chunking. It just works better for COBOL because you can subdivide things based on logical areas in the code versus fixed chunking will break that relationship and it makes the relevancy less useful. For other types of things, there may or may not be a difference, but this was a COBOL focused thing, so that's what we went with. Pipeline. Obviously, you take your chunks and you have to load them into the index first. That's step one. Then when the user searches for things, Pinecone will go ahead and rank chunks and return best 5, 10, 20, whatever you've asked it to return for you. We take those chunks and we assemble them into a payload that gets sent to the LLM. We are using Gemini 2.5 Flash Lite because it is honestly the fastest out of all of the ones that we've tested. And for streaming, we went with JSON-L. We went originally with SSE and it wasn't reliable in the browser, so I switched it to WebSockets. Here's a screenshot. I'll do a demo later. Stats on the top. It aggregates over all of the queries that you do. You have your query input. You can ask the UI to suggest options for you, models, verbosity, the number of chunks you want returned, whether you're streaming the results. L1 cache, I'll talk about that. It's caching the RAGs in advance, and trimming is an optimization. You can see we are doing some decent times with short responses and some caching. Average retrieval. Reasonably fast. We've hit our under 3-second target for both succinct and even regular results. And then we also did a second pass on all of these different verbosities and had them graded by Claude Opus to see whether they were still accurate, and Claude gave it overall acceptable scores. Development testing. Basically free. I'm not going to go into much detail on this. Production cost. Gemini Flash is not that expensive, so even if you scale it out, it doesn't seem to be that much of a burden. We are making assumptions. We always have to make assumptions. I'm just going to say it's not that expensive. AI tools and workflow. All the decision-making was generally run through Claude first. The architecture, the design, a lot of the initial implementation done through Claude. Codex is the backstop. Codex double-checks what Claude does. Codex fixes focused change requests, that sort of thing. And then Gemini does all of the UI, did the initial mock-ups that were then decided on, has done all of these slides. If there's any errors in these slides, you can blame Gemini for that. Claude defines the prompt for the slide. Gemini renders the prompt. I've found that to be a really good workflow. Architecture. A lot of benchmarking. Except for this first part. This was just determined during the pre-phase because managed for this shortened cycle makes a lot more sense. Paragraph level chunking had a much higher relevancy, so we went with that. We did test re-ranking and hybrid in benchmarks. They added latency and did not perform any better. Specifically in terms of re-ranking, it was significantly worse. SSE to WebSocket. Started out with SSE. That's typically how you would stream. But WebSocket is much more reliable, and honestly, it's a better solution. And then Gemini Flash Lite is what we went with as the LLM. Prompts that drove results. I'm not going to go through all of these. The one I do like the most is X had a baby with Y. I think it's a great way to frame something when you've got a couple of different factors going on, and it really gives the LLM something to bite into when it's kind of trying to come up with a concept or a prompt. And I'll just leave this here. I need to do a quick demo. So here we go. Here's the actual application. We can do suggestions. We can do, pick something like, that one apparently doesn't have any results for us. Let's look at something else. Here we go. So what we're looking at here is suggested. There were 200 suggestions that I pre-built, distilled out of the code base, and we can just continue to pick any of them. You'll see that the responses are very fast. So we're caching some of these suggestions, so that is a factor, but we can turn that off. The total time to get a response is quite quick, and that's using Gemini 2.5 as the LLM. We are on the tightest verbosity, and I can turn some of this off, and let's not do detailed because that'll take a long time, but we can turn some of the caching off, still stream, get a longer regular response, and we're still going pretty quickly. These are the results down here at the bottom. You can see the underlying COBOL if you want to. And then just for debugging purposes, the entire JSON-L stream is available at the bottom. So there you have it. That is my demo. Thank you for watching.